Good morning, everyone. Okay, so today we will actually learn about testing for aldehyde and ketone. Okay, so we have learned about 4 testing involving testing for aldehyde and ketone. So the part that we need to actually look at will be, okay, the first one is going to be 2,4-DNPH, okay, which will give you a deep orange precipitate. Okay, and this DNPH is used for both testing for both aldehyde and ketones. And if you look at the structure of DNPH, it's very important to know the structure. The structure is going to be, you need to put the NO2 there, and then NO2 there. Okay, and this one is connected to nitrogen. Okay, it's connected to nitrogen. And then they are also connected to, okay, NH2. And then connected to hydrogen. Okay, you need to actually memorize this. Okay, so this one will actually give you, this is DNPH. So you just need to know how, if let's say you have aldehyde and ketone, how do you write the equation? So if I just put it down over here, if I just take this and paste it over there. Okay, now, if you look over there, if I have this, okay, reacting with this ketone, for example, what's going to happen is, okay, the hydrogen, the H2, okay, and the O, okay, they will actually react, okay. It will give you water, okay, plus water here. And then they are going to give you a molecule. So I'll just redraw the molecule. NO2, NH. And then this one will have double bond, carbon, CH3 and CH3. Now, this is the molecule, okay, that will be produced. And this molecule's name is going to be 2,4-dinitrophenylhydrazine. And this is the one, okay, this is the molecule that will give you the deep orange precipitate. So the deep orange precipitate, okay, is actually given by this molecule, deep orange, okay. Now, if you move on, okay, there are Tollen'S reagent. Okay, Tollen'S reagent is going to be a mixture of silver nitrate and ammonia, silver nitrate and ammonia. And then the reaction, okay, is for as a test for aldehyde. And then the reaction is basically for silver ion is changing into silver. So they will give you the mirror-like appearance, okay. So this is going to be, let's see. This is going to be, hold on. Now, this one is going to be giving us a mirror-like observation, and this is going to be used for test for aldehyde. Now, for Fehling's solution, okay, Fehling's solution is done, okay, using Cu2 plus alkaline, and the important thing is you need to warm. Okay, here no need to warm. Okay, for Tollen'S reagent, no need to warm. Okay, it's not warmed, but here you need to actually provide heat. Okay, so Fehling's solution is copper 2 plus. The function is going to be copper 2 plus. It's going to change into copper plus. Okay, basically Tollen'S reagent and Fehling's reagent, the way they function, they are mild oxidizing agents. So they are generally oxidizing aldehyde. They are oxidizing aldehyde. So if you test with ketone, ketone don't have any reaction, okay, with both aldehyde and toluen. Okay, now, so the observation, the positive observation, if you are using aldehyde, okay, you are going to change the blue solution of Cu2 plus the Fehling's solution into orange precipitate. Take note. Okay, for the fourth reaction, it's going to be triiodomethane reaction. Triiodomethane is CHI3. Okay, so what do we have? Okay, the solution is made of, okay, alkaline solution, which is going to be from sodium hydroxide. So it's a mixture of I2 and NaOH solution, and we are going to warm as something like the previous reaction, Fehling. So we are going to warm it, and it is going to actually give you a yellow precipitate. Okay, the yellow precipitate is actually an indication that CHI3 is being formed. So we can use this triiodomethane reaction for ethanol, okay, for methyl ketones or alcohol that has CH3, OH, and H group over there. So we can actually use it to test. So if I actually put it in a form of equation, what exactly happens over here? So if you have, okay, any compound that has this C double bond O and CH3, if you have that compound, okay, so triiodomethane is important. You need to know that they are going to test for this reaction, okay, and for this group, okay, if you have this group, they can actually give you a positive reaction for a carbonyl compound. So if you have this compound, okay, generally they will give you a positive reaction. So when you react, okay, because we have I2 and NaOH, what's going to happen? Okay, the I2, okay, will actually substitute the hydrogen over there to give you this molecule, okay, to give you this molecule, and then you are going to get the byproduct of HI, okay. But once you get this molecule, we do have sodium hydroxide. Sodium hydroxide, a hydrolysis reaction is going to happen, okay. What happens is going to be this bond is going to be broken. So what happened is the RCO, okay, is going to join with NaO, okay, to give you the salt. Okay, this is the salt, and we are going to get, okay, CI3 will join with the hydrogen to give you CHI3, and this is going to be the triiodomethane. And this reaction, okay, if you warm them, okay, if it is warmed, it's going to actually give you a yellow precipitate, a yellow crystal-like structure. Is that clear, everyone? These are the things that we have learned until now. Is that okay, guys?
Yes.